Disassembling of Weichai gas engines. Weichai engine repair instructions. Removing of the gas filter. Loosen the gas pipe joint and remove the gas pipe. Loosen the fastening bolts and remove the gas filter. Removing of the heat exchanger and thermostat. Loosen the pipe joints at both ends of the heat exchanger and thermostat to remove the water inlet and outlet pipe. Loosen the pipe joints of the heat exchanger and thermostat to remove the gas pipe. Loosen the thermostat fastening bolts and remove the thermostat. Loosen the heat exchanger bracket bolts to remove the heat exchanger. Removing of the fuel metering valve. Unplug the nozzle and the harness connectors of the gas pressure and temperature sensor. Loosen the gas pipe joint and remove the gas pipe. Loosen the bracket fastening bolts and remove the fuel metering valve. Removing of high voltage line. When unplugging the high voltage line spark plug side, grab the root of the line to avoid breakage. Removing the ignition coil. Unplug the ignition coil inserting line, unfasten the ignition coil bolts, and remove the ignition coil. Loosen the bracket bolts and remove the ignition coil bracket. Removing the spark plug. Loosen the spark plug with the spark plug wrench before removing it. Removing the engine harness. Disconnect all the sensors and actuators connected to the engine harness and remove the harness clamp. Remove the engine harness. Removing the signal generator assembly. Loosen the bolts and remove the phase sensor. Loosen the fastening flange bolts of the signal generator and remove the signal generator. Removing the exhaust control valve. Loosen the connectors and fixing clamps at both ends of the exhaust control valve. Remove the gas control valve tube before removing the gas control valve. Removing the mixer. Loosen the fastening bolts of the mixer and the air inlet elbow before removing the mixer. Removing the sensors at the front and back of the throttle. Remove the sensor at the front and then remove the one at the back. Removing the air inlet manifold and electronic throttle. Loosen the air inlet manifold bolts and remove the manifold and electronic throttle. Removing the air inlet elbow and air inlet pipe. Loosen the bolts and remove both. Removing the outlet water temperature sensor and water outlet pipe. Remove the water temperature sensor on the water outlet pipe before removing the pipe. Removing the turbocharger. Remove the turbocharger water inlet pipe, oil return pipe, fuel inlet pipe and water outlet pipe. Loosen the self-locking flange nut that connects the turbocharger and the exhaust pipe before removing the turbocharger. Removing the exhaust pipe. Loosen the fastening bolts of the exhaust pipe and remove the pipe. Removing the cylinder head. Loosen the main and auxiliary nuts of the cylinder head and remove the cylinder head. Removing piston and con rod. Loosen the con rod cap bolts and remove the piston and con rod. Structure of gas engine dedicated parts and working principles. The Weichai gas engine mentioned in this part is developed on the basis of new Weichai diesel engine combined with Woodward electronic gas control system. After design improvement and optimization, the gas engine dedicated systems consist of the gas system, ignition system, air control system, etc. LNG engine operating principle. LNG flows out from the gas tank, gets heated by the carburetor and gasifies. The gas flows through high-temperature gas shutoff valves, regulators, filters, heat exchanger, and thermostat in proper order. After filtration, temperature, and pressure regulating, the gas goes into the fuel metering valve and will be accurately injected from the nozzle into the mixer to mix with turbocharged and intercooled air. Then the gas will go into the engine combustion chamber, and meanwhile the ignition system consisting of ignition coil of the ECU ignition module and the high voltage line spark plug will produce high voltage to ignite the gas mixture so that the sensor could timely monitor combustion exhaust gas and feedback to ECU. ECU will then fix the amount of gas injection, thereby correcting the air-fuel ratio. Comparing to diesel engine, natural gas engine has 3 more waterways, including the turbocharger waterway, heat exchanger thermostat waterway, and carburetor waterway. The gas fuel system of LNG engine consists of a solenoid valve, regulator, gas filter, heat exchanger, thermostat, fuel metering valve, mixer, and gas tubes. The gas fuel system of CNG engine consists of high-pressure gas filter, regulator, gas filter, heat exchanger, thermostat, fuel metering valve, mixer, and gas tubes. Solenoid valve is an LNG engine dedicated part. It plays a role in the restore or cutoff of fuel supply. It is normally closed when the engine is shut down and usually installed on the vehicle frame by OEMs. It is also the linking point of gas pipeline and gas tank pipeline, so notice should be taken during the installation to make sure that the inlet-outlet direction is consistent with the direction of the gas flow. Regulator is an LNG engine dedicated part. It adjusts the gas pressure from the gas tank to the pressure level required by the control system. The engine will run at idle speed during the adjustment of pressures. Loosen the fastening nut of the regulator and adjust the adjustment screw to about 8 bar. The balance pipe fitting on the regulator is connected to the engine air inlet pipe through gas tube, dynamically adjusting pressure at the outlet and improving gas supply reaction speed. The regulator is normally installed on the bracket by OEMs. Notice should be taken during the installation to make sure that the outlet direction is consistent with the direction of the gas flow. Gas filter, the cleaner of the gas pipeline, can filter impurities in the gas. The heat exchanger can use the engine coolant to heat up the natural gas to prevent the crystallization that enters the gas metering valve from affecting the performance of the gas metering valve. The thermostat is connected to the heat exchanger and controls the flow of the coolant flowing through the heat exchanger. To avoid high gas temperature, the fuel metering valve ECU will adjust the duty cycle of the fuel metering valve nozzle pulse width according to the engine operating conditions, thus controlling the gas injection amount to ensure that the engine is running with the set air-fuel ratio. The layout of nozzles are arranged into 2 parallel groups. WP5, WP6, and WP7 have 8 nozzles, while WP10 has 10 and WP12 has 12. Each nozzle is individually controlled by the ECU. The injections follow proper orders under normal circumstances, but the injections will be at the same time under some varied conditions. To accelerate the reaction speed of the nozzles, gas pressure sensor will measure the gas pressure and gas temperature sensor will measure the gas temperature. Mixer is the component that mixes natural gas with air, consisting of pipes and the spider joint. Natural gas goes into the mixer from the spider joint hole, making combustion more thorough and more smoothly. The gas pipe is connected to all of the gas system components, so attention must be paid to the sealing performance. High-pressure gas filter is a CNG engine dedicated component that plays a role as the cleaner to remove the impurities in the high-pressure gas line. Reducer is a CNG engine dedicated component that could adjust the pressure of the compressed natural gas from the stored level to around 8 bar. Engine coolant will be used to heat the reducer. Solenoid valve controls the supply and cutoff of the gas. Balance pipe fittings are connected to engine air inlet pipe through the air tube, which can dynamically adjust the pressure at the outlet to improve the reaction speed of gas supply. Air control system. Air control system consists of turbocharger, exhaust control valve, solenoid pedal, ECU, electronic throttle, harnesses, and related sensors. The solenoid pedal has a potentiometer and idle validation switch. The idle validation switch is normally open. When the pedal is stepped to a certain point, the switch closes and sends a confirmation signal to the ECU. The potentiometer will then function and ECU will control the opening of the throttle valve according to the potentiometer signal. ECU is the brain of the engine that is able to collect signals, calculate, process, and command actuators to work. ECU has 2 power output of 5 volt to supply the sensors, as well as grounding interfaces for the sensor and ECU. ECU uses R485 to connect the software, as well as inspecting faults and calibrating. ECU has 5 interfaces, namely G1A, G1B, G1C, G2A, and G2B. All interfaces pins have numbers. The description of the pin consists of interface description and the number mentioned above. As shown in the electrical schematics, G1B2 refers to the ignition key. Electronic throttle consists of actuator, position sensor, throttle valves, etc. ECU controls the dimension of the valve opening as well as the inlet amount of the gas mixture. At different engine speeds, control mode of throttle that ECU has include idling control mode, pedal control mode, maximum speed control mode, etc. The position sensor of the throttle measures the actual position of the throttle valve. When engine failure occurs, ECU will limit throttle opening to force the engine operate at the limp condition. There's a water tank in the intermediate shell of the turbocharger which could use coolant to cool down the engine. The exhaust valve is connected to the turbocharger bypass valve. ECU also controls the duty cycle of the exhaust control valve to control the pressure of the turbocharger bypass valve diaphragm, which would indirectly control the turbocharging pressure. The catalytic converter will turn the harmful substances in the air, such as CH, CO, NO, etc., into water vapor, carbon dioxide, nitrogen, and other harmful substances. It is a key component to achieve the emission requirements. Pressure sensor at the front of the throttle is installed at the front of the electronic throttle to measure the air inlet pressure at the front of the throttle, which could adjust the actual amount of inlet air. Inlet air pressure and temperature sensors are installed at the back of the electronic throttle to measure the pressure and temperature of the air inlet manifold, which could be used to calculate the fuel injection and control the turbocharging pressure. The humidity sensor is used to measure the inlet air temperature and humidity, which allows ECU to adjust air-fuel ratio according to measurement and make up for environmental impact so that the engine could operate at its best condition. Oxygen sensor is the lean burn control sensor that measures the concentration of molecular oxygen in the exhaust and sends the signal to ECU. ECU could determine on the actual air-fuel ratio of the mixture and conduct corresponding changes to gas injection in order to correct the air-fuel ratio. Ignition system consists of signal generator, phase sensor, ECU, ignition module, ignition coil, high voltage line, and spark plug. Signal generator is installed at the position where the diesel engine's fuel injection pump is. The phase sensor is installed at the top to collect engine speed and phase signals. The generator chainring has 6 + 1 teeth. 6 teeth are evenly distributed, representing 6 cylinders, and the other marking tooth represents the TDC of a cylinder to determine the absolute rotation direction of the engine. The clearance between phase sensor and the signal plate is 1 ± 0.5 millimeters. Ignition module receives commands from ECU and tells the ignition coil when to ignite, while monitoring the status of the ignition coil. Ignition coil plays the roles as a high-voltage generator and transformer. Primary coil has a voltage of 24 volts, while the secondary voltage is up to 2,000 to 3,000 volts. Notice that the harness should not match with the wrong cylinder. The high-voltage line will pass the high-voltage electricity to the spark plug. Notice that it should not match with the wrong cylinder. Spark plugs lights a spark to ignite gas mixture. Water temperature sensor measures the water temperature and sends the signal to ECU. Then ECU will adjust the ignition advanced angle and gas mixture concentration according to the water temperature. Harness assembly consists of ECU harness and engine harness. ECU harness is connected to ECU. ECU harness is equipped with a fuse box with fuse and relay inside. Engine harness is connected to the actuators and sensors of the engine, as well as to the ECU harness. Natural gas engine has a high exhaust gas temperature, therefore the temperature performance of exhaust-related components needs to be strengthened, including cylinder head, valve seat ring, valve, exhaust pipe, turbocharger, pistons, etc. Install the spark plug at the position where the diesel engine's injector is. Gas engine dedicated valves are made of anti-wear and high-temperature proof materials. Dedicated valve seat ring is made of anti-wear and anti-temperature proof materials. Dedicated piston rings and valve oil seals can better prevent burning oil. Dedicated piston uses enlarged internal cooling oil channel to get better piston cooling performance. Exhaust pipe is wrapped with one layer of insulating material to effectively reduce exhaust temperature. Assembling of Weichai natural gas engines. Repair instructions of Weichai natural gas engines. Cleaning requirements for piston and conrod are the same with the same type of diesel engine parts. Clean the oil stain on the piston, conrod bush, cylinder head, valves, and other components. Check the appearance of the components for damages. Install the piston, conrod, and cylinder head according to the procedures of the same type of diesel engine. Install piston, conrod, and cylinder head. Torque requirement for the con bolt rods, 170 to 250 Newton meters. The con rod bolts are disposable. Main bolts of the cylinder head should be tightened in sequence with the tightening torque of 240 to 340 Newton meters. Install the water temperature sensor and check the water temperature sensor threads. There is another sensor on the water outlet pipe that provides signals to the instruments in the cab. Please note the differences between the two sensors. Install the air inlet manifold and the air inlet elbow. Note, prevent air leakage so as not to affect engine power and tighten the bolts. Check the surface and joint surface of the air inlet elbow before installing the air inlet elbow. Tighten the fastening bolts to prevent air leakage. Installing the electronic throttle. Check the joint surface and appearance of the throttle before installing the electronic throttle. Tighten the fastening bolts. Notice that the direction arrow on the throttle should be consistent with the air inlet direction during installation. Install air inlet pressure and temperature sensors. The sequence can be changed, but the harness shall not be wrongly connected. Install the pressure sensor at the throttle's front. Installing the mixer. Check the surface and joint surface of the mixer. Apply 510 glue. Check the thread at the air inlet position of the mixer and tighten the fastening bolts. Installing and adjusting the signal generator. Install the signal generator in the gear chamber and tighten it. Press the phase sensor into the pad of the signal generator and fix it. Adjust to compressing the TDC of cylinder 1 and adjust the chainring of the signal generator to allow the TDC marking on the chainring to contact with left side of the magnetic read of the speed sensor. Tighten the chainring lock nut. Install and fix the signal generator cover. Installing the heat exchanger. Check the appearance and fittings of the heat exchanger. Install the heat exchanger and tighten the bolts. Installing the thermostat. Check the appearance and fittings of the thermostat. Install the thermostat and tighten the fastening bolts. Inlet marked with in, outlet marked with out. Installing the gas filter. Check the appearance and fittings. Drain outlet downward and gas flow direction is consistent with the direction of airflow. Installing the gas filter. Installing the fuel metering valve. Install the fuel metering valve to the bracket. Tighten the bolts and note the air inlet direction of the gas metering valve. Installing the ignition coil. Install the ignition coil on the inlet manifold and tighten the bolts. Installing the gas pipe. Tighten the fixing joints of the gas pipe and test the sealing performance of the gas pipeline. Installing the exhaust pipe. Check to see if the exhaust pipe is broken. Install the exhaust pipe and tighten the bolts to prevent air leakage. Installing the turbocharger. Place the turbocharger washer and install the turbocharger. Tighten the bolts and install oil return pipe, oil inlet pipe, water inlet pipe, and water outlet pipe. Tighten all the fastening bolts. as well as the connector. Installation and use of Weichai natural gas engine diagnostic software. Hello everyone, now we are going to learn about installation and use of Weichai natural gas engine diagnostic software version 2.0. The instruction today is going to consist of 5 parts. 1. Software installation and connection. 2. Fault codes processing. 3. Diagnostic mode. 4. Downloading programs. 5. Other features. The version 2.0 software we're dealing today is the primary system. It can be installed on Windows XP and Windows 7. Before the installation, make sure that your computer has .NET Framework 4.0. Otherwise, Toolkit won't be successfully installed. How to install .NET Framework 4.0? Double-click the icon, select I have read and accept the license terms. Click Install and wait for completion. How to install the Diagnostic Software Toolkit 4.1.1. Double-click the icon and click Install. Windows automatically installs the patch and click Next. Select Agree and click Next. Click Close after installation is complete. After the software installation is complete, open the software diagnostic interface using following ways or set up a shortcut for convenience. Click Start to open Toolkit 4.1.1. Right-clicking Toolkit to select Open or double-clicking the icon, both could open the software. Right-click and select Send to Desktop to set as desktop shortcut. Afterwards, you can use the shortcut to open it. Double-click the software icon to enter full screen mode. Click Open Tool and choose Chinese to enter the Chinese interface. If English is chosen, you will enter the English interface. Use USB RS485 diagnostic cable to connect the ECU to the computer. One end of the diagnostic cable is connected to the computer and the other end is connected to the ECU. Installation procedure of the diagnostic cable driver. Connect the USB RS485 cable to the computer port and put the disk into the DVD-ROM. The computer will prompt that new hardware is found. Click Next and choose to automatically install driver. Click Next and click Finish after installation is completed. Find out the port number of the cable USB RS485 on the computer. Right-click My Computer and choose Properties. Choose Hardware and then Device Manager. Find out the USB serial port number. After connecting ECU and entering the diagnostic page, click Connect and select the corresponding COM port number before clicking Connect again. After software is installed, if it is your first time to use the software or the SID file path changes, a pop-up dialog box will be shown suggesting a lack of the appropriate version of the SID file. Click Browse to find the required version of the SID files from the appropriate directory. SID files are provided by Weichai. If necessary, please contact your local Weichai local service manager. The username and password dialog box will pop up. Click the drop-down menu and select the username Engineer. Enter the password in uppercase WCBIAODING3. Notice following items during connection to the ECU. Do not check this box if you have checked this box by mistake. Reset according to following steps. Click Tools in the Diagnosis page. Check this box to reset. Save changes and close. If you encounter connection issue and this pop-up dialog box shows, it is indicating that ECU data is missing. Other possible causes of connection issues include diagnostic cable damage or connecting errors. Diagnostic cable driver hasn't been installed. Diagnostic cable port number mistake. SID of the ECU data does not match the SID in the computer. ECU isn't powered or ECU failure. 2. Fault code processing. The OH 2.0 system fault code may bring following consequences: temporary and continuous light up of fault lights. Adaptive learning closes, closed loop learning closes, turbocharged pressure decreases, maximum opening of electronic throttle is limited. Electronic fan open, reduction of gas supply cutoff. Fault codes will be displayed at the top right of the software's main page. The event manager will display the current fault codes when engine failure occurs. The event manager will use a 3-digit number to represent the fault codes. You can use the following methods to get more information of fault codes. A total of 20 fault codes can be stored and displayed. After reaching 20, new fault code will automatically replace the oldest fault code. Find out the meaning of fault codes. Click on the drop-down menu to find the meaning for the fault codes appeared. E.g., the event manager shows fault code FSC 561. You can choose to view the FSC 561 fault description. You will find that this page has description of the possible condition to generate this fault. It may help you to understand and solve the problem. Or you can read the LNG Fault Diagnostic Manual for a detailed description of the fault causes and troubleshooting procedures. Both can help us understand and solve problems. Clear the fault codes. To clear the fault codes in the software, select a single fault code and click Reset to clear it. Click Reset All to clear all fault codes. Click Export to save all fault codes. Clear the fault codes of pedals from fully open to fully closed. Step on the pedal 8 successive times in 20 seconds to clear all fault codes. Other functions of the pedal. Step on the pedal 3 times in a row in 20 seconds and the fault light will flash in sequence. Read the flash code. Step on the pedal 12 times in a row in 20 seconds and the adaptive table will be cleared. Three, diagnostic mode, ignition and nozzle diagnostic test. Under certain engine speed, cut off the ignition of one cylinder or the gas supply of one nozzle to check if the engine speed changes, so as to determine if the ignition of the particular cylinder or the gas supply of the particular nozzle works properly. The ignition diagnostic test procedures are: after the engine is in idle running state, connect the computers and ECU and enter the main diagnostic page. Select the ignition nozzle diagnostic mode. To enter the nozzle ignition diagnostic mode page, change the 0 in the item of ignition diagnostic input to 7. 7 represents activation as shown by the figure on the right. Click Start to estimate remaining time for diagnosis. If the countdown begins, then it means activation and cutoff test can be performed. Select the needed channel for the cutoff test in the manual ignition cutoff column. The ignition channels in the software are arranged according to the firing order, rather than the order of each cylinder of the engine. Check the engine's speed curve changes. If the changes are continuous, then it indicates that the cylinder's ignition works properly. If there's no speed change, then it indicates that the cylinder's ignition fails and you need to carefully examine the cylinder's ignition system. Input 0 in the item of ignition diagnosis. To exit the diagnostic mode, nozzle diagnostic test procedures are: enter the nozzle ignition diagnostic mode page and change the 0 in the item of active diagnosis to 7. 7 means activation while 0 means off. Estimate the remaining time. If the countdown begins, it means activation and cutoff test can be performed. Select the needed nozzle number in the nozzle manual shutdown column. After selecting the appropriate nozzle, if the engine speed changes, then it means that nozzle works properly. If there's no speed change, then it means that the nozzle does not supply gas, and you need to carefully check the nozzle's gas supply issue. Input 0 in the diagnostic column to exit the diagnostic mode. Electric throttle diagnostic test. When the electronic throttle works, the ECU command is consistent with the feedback value from the electronic throttle value. Under the pedal control mode, the command value and feedback value of the electronic throttle synchronously change with the pedal. So when performing an electronic throttle diagnostic test, change the pedal on purpose to see if the command value and feedback value of the electronic throttle synchronously change. Turn the key switch to the on position. To power the ECU without starting the engine, connect the computer to enter the main diagnostic page. Select the throttle diagnostic mode to enter the throttle diagnostic page. Change the 0 in the item of diagnostic mode to 7. If the countdown begins, then it means activation. When testing, repeatedly step on the pedal and observe if the throttle command value and feedback value change synchronously. If the changes are synchronous, it means that the throttle is okay. If the changes are not synchronized, then it means that the throttle does not work properly. Exhaust control valve diagnostic test. When performing the exhaust control valve diagnostic test, ECU will send out exhaust control valve duty cycle instruction. At this point, use observation and listening to see if the exhaust control valve works. So as to determine if the exhaust control valve is intact, select the exhaust control valve diagnostic mode. To enter the exhaust control valve diagnostic page, change the 0 to 7 in the item of diagnostic mode. If the countdown begins, then it means activation. When the remaining time is 0, stop the diagnostic test. When testing, stay close to the exhaust control valve to find out if it works. Sound and action means that it's normal. Due to the presence of impurities in natural gas and impurities entering the gas filler, nozzles need to be cleaned, which requires specialized cleaning equipment. Enable the clean function in the diagnostic software simultaneously to stop any actions of the nozzle. This will make sure that the cleaning agents can be recycled to keep away the impurities attached to the nozzle. Select the diagnostic mode and enter the nozzle cleaning mode. Follow the instructions on the page. After the countdown activates, the cleaning will start. The cleaning will stop when the remaining time is 0. 4. Download programs. Downloading programs refers to data flashing, which is to download the special SCP file into the ECU. Open the diagnostic page, click File and select Load Application. Select the File dialog box and click Browse. Select the SCP file you wish to flash from appropriate path and then click Next. Uncheck this option and click Next. Select the COM port and click Next. The downloading progress dialog box will pop up and wait for completion. Notice that during this procedure, power should not be cut off. After data downloading is completed, click Close. If the downloading process is aborted or canceled, the ECU might not be connected properly. At this point, we can use a special jumper to force the ECU to enter the source code mode. Plug the jumper connector to G1A1 while other connectors remain the same. Turn off the key switch and remain about 10 seconds. Restart the key and click Load Application. Re-download the SCP file and follow the prompt to click Next. Imperatively download the program until the download is complete. 5. Other functions. Adaptive data. Enter the main page on the computer and select the Closed Loop Adaptive Data option to enter the Closed Loop Adaptive Data page. The adaptive data is what we use to determine the concentration of the gas mixture. When the positive value is greater than 0.2, it indicates that the mixture is lean, which means gas supply is not sufficient. You need to check the gas supply system for leakage or blockage. When the negative value is less than negative 0.2, it indicates that the mixture is concentrated, which means abnormal ignition or gas supply. Need to clear the adaptive coefficient method pedal clearing method. Step on the pedal 12 times in a row in 20 seconds from fully open to fully closed to clear the adaptive data table. Select all the data in the adaptive data table. Right-click and input 0. After clicking Finish, the clearing will be finished. Data curve. Right-click on any parameter to pop up Add to Trend, and this parameter can be displayed in the form of a time curve. Click Start to begin sampling. Click Properties on the curve to modify the properties of the display parameters, such as maximum, minimum, sampling time, etc. The number of parameters showing has no limit, so you may choose to introduce multiple parameters, but when too many parameters are displayed, the result after you save could be confusing. Speed limit. Enter the main page on the computer. Choose from the drop-down menu to select Speed Limit Control RSG. To enter the speed limit control calibration interface, put down the speed limit data according to the requirements of OEMs. Signals are received from the CAN instruments. Select telegraph vehicle speed from J1939 CAN and both set speed limit. Click Finish. When receiving signals from the vehicle speed sensor, select SPDR to receive signals from the vehicle speed sensor. Enter the conversion constraints EOL provided by OEMs and set speed limit for both. Click Save to complete. Description of the main parameters on the page. Inlet air temperature is generally not higher than 60 degrees Celsius. Possible reasons for higher temperatures are mismatch or poor performance of the intercooler. Gas temperature should not be lower than -40 degrees Celsius. Possible reason for exceeding is poor circulation of carburetor heating water. Engine speed value should always be on during the startup and operation. If there is no value or interruption, it means phase sensor related faults. The pressure of the air inlet branch pipe pressure should be about 30 kPa when idling. The excessive value means air leakage of the air manifold. Gas pressure should be about 8.2 bar when idling, which is the basis of how we adjust the regulator, as well as the important reference to determine if the reactor is able to normally supply gas. Mastering the functions of Natural Gas Generator Diagnostic Software 2.0 will help us inspect and solve the problems more quickly, removing any problems of the engine and offering guarantee to the normal operation of the vehicle. Thank you for your attention. The flow of the air filters. Equipped on Weichai GAS engine vehicle should meet the requirements. Mining vehicles and other vehicles under harsh working conditions are recommended to use oil bath air filter. Air inlet should keep rainwater from entering and avoid inhalation of hot air directly from inside the cabin. Humidity sensor is installed in the air pipeline between the air filter and the inlet of the turbocharger. Sensor probe should be installed vertically downwards to place the probe into the gas stream. The air inlet pipe connection should be reasonable, no right-angle corners or sharp corners not interfering with other components. It is recommended to use steel rings to fix the rubber pipe and then be connected with ladder clamp to the air inlet pipe. The internal diameter of the front and rear air inlet intercooling pipes should meet the minimum internal dimension requirements. The temperature of the intercooled air has a profound impact on the power performance of the engine. The engine compartment needs good ventilation and heat exchanging. Ventilated at the front side should be perfect if it's arranged on the front of the vehicle. Exhaust system. The internal dimension of the vehicle exhaust pipe should meet certain requirements. The inner surface of the exhaust pipe should be smooth and the pipeline should be free from right-angle corners and sharp corners. It is suggested to wrap the outside with heat insulating materials. Oxygen sensors should be installed at the position that is 3 to 5 times of distance of the exhaust pipe diameter from the turbocharger outlet and cannot be installed around the exhaust pipe corner. The mounting position should be after the exhaust brake, and installing it vertically would be the best option. Oxygen sensor harness and connectors heat insulation should stay away from the exhaust pipe and be connected securely to prevent sintering. LNG tank pressure should not be lower than 8 bar, otherwise it would lead to insufficient gas supply. The mounting position of the carburetor should not be higher than the top of the radiator. Water would come out of the water outlet pipe of the engine flywheel end. Water pipe should be fixed and not be flattened or touched. The pipe should also be smooth without sharp corners and be away from the exhaust pipe. The distance from the carburetor to the engine water inlet should be within 3 meters. Vehicle gas pipeline. The internal diameter of steel LNG pipe should be greater than 510. The gas pipe layout should be reasonable and free from impact or friction with adjacent components. ECU and ignition module are usually installed inside of the cab in order to be dustproof, waterproof, and shockproof, as well as to be away from heat and electromagnetic sources. Avoid bumps and other damages during installation and remove all surface coverings. Use electronic pedals Weichai recommended or pedals with parameters that meet the technical requirements of Weichai. Connecting wire that connects pedal and ECU harness should be prepared by OEMs. The connection should be proper. Harness, engine harness, and ignition harness should be installed on the engine. ECU harness should be installed by OEMs and following connections should be made. To oxygen sensor, humidity sensor, solenoid valve, ignition module, ECU engine harness, pedal transition line, ignition harness grounding earth wire. Connect with the vehicle connector. The pins of the vehicle connector are represented by uppercase and lowercase letters. For example, uppercase A means 24 volts, positive, uppercase J means negative. Lowercase p represents the ignition key and N represents fault lights. Repair and maintenance of Weichai GAS engines. Proper and timely maintenance can greatly reduce the failure rate of the engine, reduce maintenance costs, and prolong engine life. Because the engine is electronically controlled, the engine surface are full of electrical components and circuits. Therefore, it is not allowed to use water to wash the engine. Specific maintenance requirements are as follows. Regularly change oil and filter. Use oil for natural gas engine or CH4 and above oil for diesel engine. Replace the oil filter while changing oil. First oil changing time should be after driving 3,000 kilometers. Routine oil changing intervals for mining vehicles and other vehicles working under harsh conditions should be after 8,000 to 10,000 kilometers. Routine oil changing intervals for on-road transportation vehicles should be after 15,000 to 18,000 kilometers. Replace antifreeze. Note, select proper antifreeze and deflate at the carburetor outlet. It is essential to choose the right kind of coolant, for it also serves the role of heat exchanger for the carburetor. The minimum temperature standard of the coolant should be 20 degrees lower than local minimum temperature. When changing antifreeze for LNG engines, deflate at the carburetor outlet. Regularly check the water passages for connections. Check if the water pipes have aging, cracking, or flattening bottom. If so, deal with it in time. Check the air pipeline. To maintain good performance of the air filter, regularly purge the filter and periodically replace the filter element. Regularly replace the oil in the oil-bathing air filter to prevent dust from entering to cause premature wear. Regularly check the air inlet manifold for aging, cracking, or perforation problem. See if the clamp is loose. If so, tighten or replace it to ensure the sealing performance of the air inlet manifold to prevent air leakage. Regularly purge the intercooler. Check and adjust the valve clearance. Valve clearance must be checked and adjusted after the first 20,000 kilometers. After the first 20,000 kilometers, check the valve clearance when performing eye-level maintenance. Adjustment methods are the same with the same type of diesel engine. When performing the routine gas filter check, clear the dirt after the system pressure is released. Close the gas tank during replacement and clear out the dirt after pressure is released. When performing eye-level maintenance, replace the gas filter element, unscrew the filter housing, and unscrew the plastic cap before the filter element to replace the element. Screw back the parts in proper order and tighten them. When performing routine check on the regulator, check fittings for air leakage. Replace the regulator repair kit when performing two-level maintenance. Replacement steps are as follows. Turn off the gas tank valve and loosen the lock nut of the regulator. Rotate the adjustment screw clockwise to empty the internal gas and remove the regulator. Place the regular valve cover side upward and loosen the adjusting screw. Separate the valve cover with the valve body and remove the spring button, large springs, thin plate, and stem button in order. Place the regular base side upward, loosen and remove the base, valve seat components, and small springs. Lubricate the O-ring of the valve seat assembly with oil and install the following core in the valve seat assembly casing. Valve seat assembly, spring, and the sealing ring. Clean the valve body case, install and tighten it. Install the valve stem core components at the rear of the valve seat components. Position the core components gasket at the valve body flange and install them in the valve body. After positioning the large coil springs and the spring button, adjust the gasket plate to the center of the gasket and align the hole at the edge of the valve cover edge with the hole at the edge of the valve body. Insert screws and tighten them. Install the regulator. Test for air leakage under idling condition and adjust the pressure to about 8 bar. Cleaning the mixer. Clean the mixer with the carburetor when performing two-level maintenance. Dry it with compressed air after cleaning. Cleaning fuel metering valve. Clean the fuel metering valve and oil passages. Stop the engine, turn off the main valve of the gas tank, open the fuel metering valve, gas inlet and outlet pipelines. Connect the gas inlet to the diesel outlet used to clean the toolings. Connect the gas outlet to the diesel inlet or directly connect the gas outlet to the barrel with the pipe. Circuit connection, 12-volt power is required to clean the tooling. Connect the positive and negative of the pump to the positive and negative of the electrodes respectively. Install a switch in the circuit to control the start and stop of the pump. Filling diesel. Pour approximately 6 liters of diesel into the pump barrel to let the oil level stay above the top of the pump. The diagnostic software will then shift into cleaning mode. Follow the notes to open the pump switch to pump the diesel into the fuel metering valve before letting it return to the washing pump. Cleaning would start. Repeat the above steps if you want to clean again. Cleaning the electronic throttle. During two-level maintenance, use gas line or carburetor cleaner to clean the bottom valve of the throttle. Take notice that it is prohibited to soak electronic control units in gasoline. Dry the components after cleaning with compressed air. Cleaning and drying the exhaust bypass valve. During two-level maintenance, clean the air inlet filter mesh of the exhaust control valve. When cleaning, first scrape the air inlet filter mesh with a fine wire and then use compressed air to blow from the direction of the air outlet to make sure that the mesh is free of dirt. When performing two-level maintenance for the turbocharger bypass valve, check the turbocharger bypass valve for air leakage. Replace it if air leakage is found. Disconnect the turbocharger bypass valve air inlet pipe. Connect the inspection equipment to the bypass valve air inlet. Inspection equipment include professional equipment and simple inspection equipment modified from normal inflators. When using professional inspection equipment, raise the temperature to 200 to 250 kilopascals. Visually check for sharp pressure drop. Sharp pressure drop indicates air leakage. When using simple inspection equipment, use hands to check for obvious air leakage around the bypass valve stem. If leakage happens, inspect the line. Check the contact of the connectors during routine inspection. They should be firmly fixed and harness should not come into contact or have friction with sharp objects. Nor should they intertwine or cross with other harness. The harness should not be fixed on the air compressor pipeline. The distance from the copper pipe should be greater than 50 millimeters. Harness should be at least 150 millimeters away from the exhaust pipe and the turbocharger. spark plug. Spark plug belongs to wearing parts. Check and maintain the spark plug during 2-level maintenance and replace it during 3-level maintenance. Cleaning the spark plug. Before removing the spark for inspection, use compressed air to blow clean the cylinder head surface so as to prevent dust from entering. Remove the spark plug and clean it with clean cloth strips. Use sandpaper to gently remove the rust or soot and keep the spark plug dry and clean. Remove impurities inside of the spark plug wrench socket. Remove the impurities inside of the spark plug mounting hole of the cylinder head to make sure that the spark plug installing tools and its surrounding are dry and clean. Adjust the spark plug gap clearance to 0.3 to 0.35 millimeters. Troubleshooting of Weichai GAS engines. Fault diagnosis methods generally used on gas engines include: observation. Observe the pattern of the engine fault to determine the fault. Listening. Based on the sound of the engine fault, determine the engine fault position. Software diagnosis. Use diagnostic software to determine the fault case. Comparison. Replace the assembly or component to determine if there is a fault. If the engine cannot be started or have difficulty in starting, check whether the power supply of ECU is cut off. The inspection measure is to open the key switch and observe the fault light and see if the diagnostic software can be connected. If there is no power supply to the ECU, check to see if the ECU connectors are loose or insurance pads, relays, and the AJP in the vehicle interface are functioning. In that case, the malfunctioning happens. Check the vehicle circuits or battery. Check the ignition system to see if the ignition works. Take the high voltage of cylinder 1 and plug in the spark plugs to let the electrode at the spark plug side be grounded. Start the engine. Check to see whether the spark plug generates sparks or not. If not, check to see if the ignition grounding line is properly connected. Check for poor contact or component failure between the ignition module and the ECU harness. Remove and inspect all the spark plugs to see if there are ablation, improper clearance, or watermarks, etc. If watermarks exist, check the cylinder heads for water leakage. Check to see if the gas supply system is functioning. Check if the LNG tank and buffer tank gauge are above 8 bar. If not, repair LNG tank, liquid outlet valve, overcurrent protection valve, and other pipeline components. Check the interface to see if the value of the gas pressure is around 8 bar. Open the solenoid valve, regulator, gas metering valve, air outlet pipe in sequence to test for gas. Identify the fault and check if ECU could receive speed signals or if the ignition timing is correct. Check for speed signals with the diagnostic software when you start the engine. Further check the phase sensor and its connectors to see if they are loose or damaged, or check if the ignition timing is correct. Check for loose chainring if they are incorrect or if the signal generator shaft has fractures. Check whether the electronic throttle is working properly or not. Open the diagnostic software and enter the throttle test mode to see if the electronic throttle is working properly. Check whether the gas mixture concentration is within the combustible range or not. If the high nitrogen content of the gas causes lean mixture, empty the nitrogen in the gas bottle and refill the natural gas. Also, check if there's nozzle leakage that leads to high concentration of the mixture. If so, the gas metering valve and valve clearance, as well as if the valve tappet is bent, that leads to an underpowered engine. Observe the air pipeline clamps from the air filter to the mixer to see if they are loose. Check the gas pipeline for icing and check the harness and high voltage connectors are working properly. Use the software to see if there are any fault codes. Remove the faults from easy to difficult. For example, fault 431, low gas pressure, is brought up, and after investigation it is confirmed that the pressurized valve of the gas bottle chamber doesn't open. The gas supply is insufficient during vehicle operation. Use the test mode of the diagnostic software to determine if the ignition or nozzle works properly, such as to see if cylinder 5 ignites properly. That is to say, you can use observation and comparison to test cylinder 5's high voltage ignition coil, harness, ignition module for poor connection, component malfunction, or you can further check the air inlet pipe around cylinder 5 for air leakage. Observe relevant parameters in the diagnostic software to find fault information, such as when the engine is idling. If the air inlet manifold pressure is 52 kilopascals, then it indicates air leakage of the air inlet pipe. Observe the oxygen sensor to see the feedback value changes, so as to determine if the mixture concentration is normal. Observe the adaptive gauge to determine if there is a gas supply or ignition abnormality. Check to see if gas filter, nozzle, and mixture gas pipeline are timely and cleaned and maintained. If maintenance is not in place and the gas pipeline components are too dirty, the gas pipeline will be blocked, resulting in insufficient gas supply and affecting engine power. Check if the solenoid valve and regulator works properly. Check if the spark plug clearance is normal, if the electrodes have ablation, and if the insulator has electricity leakage. Check if the high voltage line and ignition coil have electricity leakage, if the ignition timing is normal, and if the valve clearance is normal. Check for air leakage between the pipes of the turbocharger exhaust gas control valve. Check for leakage or blockage of the air pipeline and components between the air filter and the air inlet pipe. Particularly check the intercooler for air leakage to see if the turbocharger works properly. Check if the exhaust control valve works properly. Check the exhaust system for air leakage or blockage, such as exhaust pipe cracks or breaking. Air leakage of the turbocharger gasket or exhaust brake valve not opening. Check the harness for poor contact, such as if the harness connector has water seepage, if the connection is loose, or if there are short circuit to open circuit between the harness. Check the cylinder pressure. Check the sealing performance of the cylinder head valve sealing and the piston ring to see if the engine itself works properly. Perform vehicle test using diagnostic software to observe if the turbocharged pressure, gas temperature, engine water temperature, and air inlet temperature and other parameters are normal. Determine the cause of the fault according to the situation. Abnormal blasting sound of the engine. This refers to the combustion mixture in the inlet and exhaust pipe. The causes may be malfunction of the spark plugs and other ignition system components, wrong matching between the high voltage line, ignition coil, and corresponding cylinder, wrong valve clearance, or wrong ignition timing. Unstable engine idle are mainly caused by failure of spark plugs, high voltage line, ignition coil, and other individual parts of the ignition system. Malfunction of the fuel metering valve nozzle, air leakage of the air inlet pipe, malfunction of the oxygen sensor, improper valve clearance, electromagnetic interference, or malfunction of the electronic throttle, or the water temperature sensor failure. Promise, fulfill, even more thoughtful. We spare no effort to provide customers with professional services of Weichai GAS engine. Weichai Westport New Energy Engine Company Limited is a joint venture company set up by Weichai Holdings Group, Westport Company of Canada, and Peishin of Hong Kong, specialized in developing and manufacturing new energy engines. The construction area of the company plants cover over 50,000 square meters, and the plant has an annual production volume of 15,000 units of new energy engines, including WP5NG, WP6NG, WP7NG, WP10NG, WP12NG, and WP13NG. The power range of the engines cover 120 kilowatts to 330 kilowatts, and they can be applied on urban houses, highway buses, heavy trucks, and in other applications. Over the years, Weichai has been committed to the research and development of gas and new energy engines. Back in the late 1970s, Weichai successfully developed diesel-gas genset on the basis of 6160 engine, opening the prelude of Weichai's development of gas engines. The company has undertaken the projects of 9th and 10th five-year plans, as well as 836 projects, which led to fruitful results in new product development. In recent years, Weichai has been increasing R&D effort and investment in gas engines, and the experimental equipments have reached the world-class level. The gas engine laboratory covers an area of over 6,000 square meters, including 2 HPDI test benches and 10 automated performance test benches, all equipped with transient AC power test system, sulfur emission test equipment, combustion analyzers, and entire set of ETC cycle emission testing equipment. The lab has combustion and performance development and calibration capability for China 4 and China 5 gas engines. In 2000, the 75 kilowatt single fuel genset was successfully developed. In 2012, WT61500 LPG was successfully developed. In 2004, Steyr and Deutz turbocharged and intercooled gas engines were successfully developed, allowing the combustion of the engine upgrade from the theoretical air-fuel ratio burning to lean burn. The emission standard of the engine reached China 3, and the power and economy of the engine increased profoundly. In 2005, the 380 HP gas engine was developed, filling the gaps in high-power engine market. On July 16, 2008, Weichai Power, Westport Innovations Incorporated of Canada, Hong Kong Peishin, and China Investment Company signed the joint venture agreement in Beijing. In March 2012, Weichai and Westport jointly completed the development for China's first in-cylinder direct injection LNG engine, WP12 HPDI. The development filled up the gap in in-cylinder direct injection engine in the Chinese heavy-duty truck market. Weichai GAS engine are developed based on mature diesel engines, according to the characteristics of natural gas engines, piston cooling, turbocharger cooling. Valve and valve seat have been redesigned matching with the sophisticated and reliable electric gas control system. The power and reliability the engine could reach the same level of the diesel engine. WP5 engine is a 4-cylinder engine with integral cylinder head. The rated power is around 165 to 180 HP and the displacement is 4.76 liters. It can be applied on buses under 9 meters and passenger cars under 8 meters. WP6 engine is a 6-cylinder engine with individual cylinder heads. The technology of the WP6 basic engine comes from Deutz. The stable power is 210 to 240 HP and the displacement is 6.75 liters. It can be applied on buses under 11 meters and passenger cars under 10 meters. WP7 engine is a 6-cylinder engine with integral cylinder head. The rated power is around 210 to 270 HP and the displacement is 7.14 liters. It can be applied on port vehicles and highway transportation vehicles lighter than 40 tons working with good road conditions and less demanding vehicle speed, as well as on air-conditioned and non-air-conditioned buses and passenger cars from 10 to 12 meters. WP10 engine is developed based on mature stair engine technology. The rated power of the engine is 220 to 336 HP, and it is the classic heavy-duty truck engine. With high reliability, good economy, high torque backup, the engine can be applied on highway transportation trucks and dump truck with a total weight of 60 tons or less, air-conditioned and non-air-conditioned buses and passenger cars of 11 to 18 meters, construction machineries, ships, and gensets. WP12 engine is developed based on mature Land King engine technology with full intellectual property rights. The rated power of the engine is 350 to 380 HP. It can be applied on mining vehicles, heavy-duty highway transportation trucks, and dump trucks operating under harsh conditions. It can also be applied on air-conditioned passenger cars above 12 meters and articulated buses above 18 meters.